Welcome back, first grade students. Today we are working in science on Unit 3, Light and Sound Communication. Lesson 7, Light and Sound Communication Portfolio. My name is Mrs. C. Today we're going to complete a portfolio that covers 4 different lessons. That means you can take your time and complete this assignment over 4 different days. You don't have to do it all at once. I'll go through all 4 lessons in this video, but you can watch it at different times to complete this portfolio a lot slower than I'm going to today. Let's look at your lesson to see how we should begin. Right now, we are in lesson 4. So you can see it says portfolio 1. We're going to go all the way through to portfolio 4. That's where you'll turn in your lesson. Here is our objective. In this portfolio, you will think like an engineer about a device that uses light or sound to communicate over a distance. Our keywords are communicate, which means to share information, device, which is equipment that does a special job, light, a form of energy we can see, and sound, energy that you can hear. The engineering design process. We're going to start with ask questions. In this portfolio, you will think like an engineer. Engineers follow steps to solve problems. Look at this chart and think about each step. So you can see the very first step at the top is ask. If you ever want to see this anchor chart again, you can click right here and you can view it throughout your lesson. You will follow this process in this portfolio. The first step is to ask questions. Think about the problem you are solving and ask questions about it. In this portfolio, you will ask questions about making a device. The device has to use light or sound to communicate over a distance. So I want to show you really quickly in my science journal. Here is my ask questions section. Remember, your science journal might look different and that's okay, but you're still going to want to ask at least one question before beginning. So I asked a really simple one related to what we're learning about. Can I communicate with light and sound? So can I do that, yes or no? We're going to answer that question through this process. Let's go back to your lesson. Communicating. There are many ways to communicate with other people. You might talk to someone who is near you. You might call someone who is far away. Watch the video and learn about ways to communicate with someone who is far away. So you can watch this video with your learning coach and then think about the different devices in the video. They helped people communicate from far away. How did they communicate? Here's an activity down here. You can match up which forms of communication used sound only, light only, or both light and sound. Sometimes we use both at the same time. Think like an engineer about communicating with light and sound. Imagine you were playing a game at the park. For the game, your team hides a flag. How might you communicate with the other people on your team? Could you make a device to help you? You can think like an engineer about devices that use sound and light. In this portfolio, you will make a device that uses sound or light to communicate over a distance. You will, number 1, ask questions about a device that uses light or sound to communicate over a distance. So remember, that's what we just did. We asked a question and we recorded it in our science journal. Number 2, brainstorm different solutions for the device. Number 3, design a plan to make the device. Number 4, create the device by following the plan. Number 5, test the device to find out if it works. And number 6, improve the device to make it better. So remember, you're going to use your science journal to record your work. How to complete your portfolio. You will complete your science journal and then you will send it to your teacher. Here's the rubric. We're going to go over this at the end just to make sure we've checked off all of those sections that are going to be graded. Here's a new objective. In this portfolio, you will brainstorm a device that uses light or sound to communicate over a distance. The keywords are device, a tool that does a special job, light, a form of energy we can see, and sound, a form of energy we can hear. brainstorm. In this portfolio, you will brainstorm possible solutions to a problem. Look, it's the second part of the engineering process. How to brainstorm. Watch the video to learn more about brainstorming. You will brainstorm possible solutions to the problem of how to communicate over a distance. Your ideas may use sound, light, or both. Devices that use light or sound. Use these flashcards to learn more about some devices that use light or sound. So you can click on these to view them, and you can review some different objects that exist already. Here are some questions you can talk about with your parent or caretaker. What step comes after asking questions in the engineering design process? What is the focus of brainstorming? Should you evaluate your ideas when you brainstorm? So should you see if they're really possible or not? All right, so here's our next step that we're going to be turning into our teacher. Science journal. Brainstorm ways you can use sound or light to communicate over a distance. You can try starting with these sentence starters. I can use light to communicate over a distance by blah, blah, blah. I can use sound to communicate over a distance by blah, blah, blah. Brainstorm your ideas in your science journal. So I made my sentences just a little bit shorter just because this is first grade and I didn't want them to be too long, so I took out the over the distance part. But I said, I can use light to communicate with flashing patterns, or I can use sound to communicate with bells or whistles. Remember, you can use light, sound, or both. So you don't have to do both options, but you have to do at least one. All right, so brainstorming, that is the second part we will be turning into the teacher for a grade. So make sure you have that written down in your science journal. This is the end of lesson 4. So I'm going to go to my course outline and go ahead and go to lesson 5. This is a good stopping point for day 1. You've already asked questions and you've already brainstormed. So if you want to pause here, then you can pick up and continue working tomorrow. Here's our objective. In this portfolio, you will design a device that uses light or sound to communicate over a distance. Here are those keywords again. Communicate means to share information. A device is equipment that does a special job. Light is a form of energy we can see, and sound is energy that you hear. In this portfolio, you will design a device to solve a problem. This is an important step. It's the next step in the engineering process. Remember, engineers do these things. They look at their ideas. They pick one solution out of all their brainstorming that they think will work best. They make a plan that includes this: the lists of all the things they will need to build their device and a list of the steps they will take. Remember, if you ever need to look at this design process again, you can click that anchor chart. Designing a plan. Watch the video to learn more about design. When you're done, talk about these questions with your learning coach. How did the student use light to solve the problem? How did the student use sound to solve the problem? What steps come after brainstorming? What is the focus of the design step? What are some important parts to include in your plan? Now it's your turn. Look at the possible solutions you have and choose the best one. Make a plan to design the best device that uses sound or light or both to communicate over a distance. So here are some sentence starters that will help you with the design process. Remember, we need to include the materials that we need and the steps for our plan to test it. You're going to write your design in your science journal. You can use pictures and words. So in mine, I used words, but you can also draw pictures to show what you'd like to do as well. So for my design, I'm going to use items I already have in my house, and I'm going to test them to see how I can improve them and make them better so I can communicate. So I need for my materials list a flashlight, a bell, and a whistle. I'm using light and sound. Here are my steps. Number 1, gather the materials. Number 2, use my hand to cover the flashlight slowly or quickly. Number 3, use a bell for fun messages. And number 4, use a whistle for warnings, right? That's that harsher sound. It's definitely going to get your attention. So that's my design process with my materials, the things that I need, and the steps, what I'm going to do to test those devices. All right, so that's the end of lesson 5 or step 2. You can go ahead and stop here if you'd like, and you can continue on tomorrow. in lesson 6, which is step 3. In this portfolio, our objective, what we want to do, is to create a device that uses light or sound to communicate over a distance. Here are some of the keywords we've already reviewed. Device, which is equipment that does a special job. Light, a form of energy we can see. And sound, energy that you can hear. Now we're going to create. In this portfolio, you will create a device to solve a problem. This is an important step. It's the next step in our engineering process. Engineers do these things. They use their plans, they follow all the steps, and this helps them to build their solution. When they create, they might have problems. If they do these things. Change their plan, write down new steps, try again. Creating your device. When it is time to create your device, you will do these things. Work by yourself. Remember, this is your plan. You can get help, but make sure you're doing the thinking and the trying. Use your plan, get the materials, and follow the steps you wrote down. You might have some problems while you work. That's okay. You can solve those problems. When you do, write down your changes. After you finish, make sure you clean up after yourself. When you work on your own, you are using the 21st century skill known as working independently. This means that you work by yourself. You get your own materials, you solve your own problems, you write down your own steps. Then when you're done, you clean up by yourself. Remember, you can always ask for help. There's nothing wrong with that, but you want to do as much as you possibly can independently. That will help you learn the best. Talk to your learning coach about the engineering design process and answer these questions. What step comes after designing in the engineering design process? What is the focus of the create step? And what can you do when you have a problem with your plan? Now it's your turn. Look at the plan you made. Use your plan to create your device that uses sound or light to communicate over a distance. So you can write about what you've done. You can draw pictures about what you've done. You can even take a picture of what you've done. So if you've made your own device where you actually made maybe a cover for your flashlight, maybe a string that you can pull for your bell, anything like that. If you want to take photos of what you really did, I'm sure your teacher would really love to see that work. I drew pictures in my science journal. So I showed my flashlight. I'm going to use one that I already have at home, but I'm going to use my hand for those flashlight signals. I might even make a cover or a flapper for the front. I might try some light colored paper to use different colors to communicate. There are a lot of things that you can discover when you actually do your experiment or your design process that you might want to add or change and investigate further. Then I've also got a picture of my bell. I'm going to use really soft bell sounds when I want to communicate something pleasant. And then I'm going to use my whistle with really loud whistle sounds when I want a warning, when something's not going well. So that is my create section. Remember, you can draw pictures. You can use these sentence starters right here, or you can take pictures of what you've done for that create section as well. You can get as creative as you would like to. All right, this is the end of step 3. We are going to move on to lesson 7. This is where you turn in your final portfolio with all of those sections of your science journal for your teacher. So in this section, we're going to finish. If you want to work on this tomorrow and pause right here, that sounds like a good plan to me. All right, what are we doing? We are testing a device that uses light or sound to communicate over a distance. That's our objective. That's what we need to do. Here are those keywords. I hope we know them super well by now. We have device, which is equipment that does a special job. Light, a form of energy we can see. And sound, energy you can hear. Test. In this portfolio, you will test your device. This is an important step. Look, it's the second to last step. We're almost done. Engineers test to see if their device works. They test it more than once. They write down what happens. You will test to see if you can communicate with sound and light, or sound or light. You don't have to do both. Remember, both or one or the other. Testing your device. Watch the video to learn more about testing a device. Think about these questions afterward. What did the student create? What is the student testing? Answer these questions too. What step comes after the create step? What is the focus of testing? And how did the student test their device? Remember, you don't have to write down these questions or answers. This is just when you're talking out loud with your parent or caretaker and you're going over those responses with your learning coach. You're just chatting about it. Now it is time to test your device. Does it work? Work with your learning coach and use these sentences to help you start. I tested to see, blah, blah, blah. I found out that, blah, blah, blah. So here is the test section of my science journal. Yours does not need to look the same or sound the same. You just want to make sure you write down what you noticed. I tested to see if I could send messages with light and sound. I found out I needed a chart to teach what my messages meant. So I tried sending messages to someone and they did not understand. So besides making my devices better by adding strings or paper or tissue or anything like that, what I needed to do to my devices is just explain how they worked. So that's what I needed to do. I found out after I tested. All right, so that's what comes next, improvements. Here's our new objective. In this portfolio, you will improve a device that uses light or sound to communicate over a distance. What is a device? It is equipment that does a special job. What is light? A form of energy we can see. And what is sound? Energy that you hear. Improve. In this portfolio, you will improve your device. That means you will make it better. You'll make it work. This is an important step. It's the last step of this engineering process. After engineers test their device, they do these things. Look closely at the results. Make changes if they see a problem. The changes should help make the device better. So you want to make changes that improve it. And if you make a change and it does not improve it, you just want to change it again. Improving your device. In the improve step, engineers return to their goal to make sure they are meeting it. When you set and meet goals, you are using the 21st century skill known as managing projects. This means that you work toward your goals even if you run into problems. You make plans so that you meet your goals. That way, you get the results you want. In this project, your goal was to make a device that uses sound or light to communicate at a distance. Look at your tests. See if you are meeting your goal. If you are not, then make changes. Answer these questions with your learning coach. What step comes after testing in the engineering design process? What is the focus of the improve step? What can you look at to help you improve your device? Remember, examples are very helpful. You might want to do some research and look up some things that might help. In your science journal, you want to make sure you record what you did to improve. You can draw pictures of the changes you made. You can write sentences. You can use these sentence starters. I noticed that blah, blah, blah. I changed blah, blah, blah. Write about how you improved your device in your science journal. You may use words or pictures. So here's my science journal. In my improve section, I said I noticed that not everyone knew my signals. I made a chart. So I made a chart to show what those flashes of light mean, what those bell sounds mean, and what those whistles mean. So for my light flashes, I used this for when my kids were playing at the park. We have a big field with a park across, and I used one light flash to give them a 10-minute warning, 2 light flashes to give them a 5-minute warning, and 3 light flashes that meant time to come home. Once they knew what those flashes meant, it worked a lot better. For my bell, we used this for dinner time. 1 soft chime, 1 little ring, that means 10 minutes until dinner. 2 soft chimes meant to wash your hands, and 3 soft chimes meant to come and eat. Dinner was done. For that whistle, remember that whistle is, I need your attention now. 1 loud whistle means stop, stop whatever you're doing. 2 loud whistles means sit down. And 3 loud whistles means go to your room. It's like a final warning, right? Whistles can be warnings. So here's my little whistle. And all I had to do, it's very loud, right? Whistles are loud. When you use a whistle, or that one's actually a kazoo whistle, when you use something like that, that gets people's attention. So it is a good way to communicate. All right, so I made a chart. That was how I improved. Remember, your improvements might be things that you actually do to your device. You might add something, you might take something away. So it might be better for you to take a picture or draw a picture of your change. All right, so reflect. Every good engineer always wants to think about what they did and think about overall what they learned and what they feel about their experiment. So in this portfolio, you designed a device that used sound or light to communicate over a distance. Now we're going to think about how we used each of these steps. The last step is to then reflect on what you did. Think about your portfolio project. Look at what you wrote in your science journal during the project. What did you change? What did you adjust? What did you add? Think and talk about your portfolio project with your learning coach, and then use these sentence starters for help. Write your answers in your science journal. And if you have more questions, if you learned a lot, but you're left with even more questions, you can write questions too. Here's my reflection. I learned that light and sound can communicate simple messages. It's a lot harder to communicate a whole sentence or a whole idea, but you can definitely use them to communicate simple messages. All right, so this is the second to last page. The next page is going to be the Dropbox where you actually submit your portfolio. But right now we want to get ready and make sure that we have every part that we need. Number one, in your science journal, you should show your page that shows ask questions. Number two, you want to show your brainstorming as well. Number three, the design process. Remember, those are your materials and your steps. Number four, create. This is a drawing or a picture of what you made. Number five, test. What went well? And then number six, improve. What can you change? So you want to make sure that you have each of these sections in your science journal to turn in to your teacher. Let's look at our rubric. Here's our rubric to make sure we have everything. In the Ask Question section, we want to make sure that we can ask a question about a problem or a challenge that people want to change. In the brainstorming section, we want to make sure we imagine different solutions to a problem and choose the best idea or best solution. In our design section, we want to have a detailed plan that can include the materials, the steps, you might have pictures. Number four, our create section. We can follow the plan that we made. We can follow those steps for our design, and we can create something that sends those messages with light or sound. Our next one is test. Remember, we want to actually use our device and see if it works. We can record our observations or what we noticed. And then if we have anything that didn't work out, we can improve as our last step. We can compare different things that worked well, different things that didn't work well. We can do research if we need to see other people's examples. We want to think of something we can do to make our device even better. And then that last section is just that reflection showing how you did as well. Mine was very short and it fit right underneath improve. So make sure that you send all of these pictures to your teacher. You can make them all in one file if you'd like to. You can take a picture of each one if you'd like to, and you can have more than one section on a page. It doesn't have to be all on different pages, right? You can fit as much as you want to. So I just used a plain notebook. You can use your science journal that's included in your curriculum. You can use anything that helps you go over all of those steps. And then, like I said, on the very next page, going back to your lesson, you're going to see a Dropbox after this page right here where you will submit that to your teacher for a grade. I know if you have each of those sections, you are going to do a fantastic job. Well done, everybody. Thank you so much for watching. I hope this was helpful. Goodbye, goodbye.